here in this video, I just want to quickly talk about how CAD ties into documentation. Okay, documentation is, at least at the world level of the competition in VEX, the most important part of the competition. It opens you up to, win all kinds of different awards, and it's like largest factor in determining who wins the design award, and a pretty big, though maybe not the largest factor in deciding who wins like excellence award, which are some of the top awards at VEX competition, right? So here I just have a CAD engineering notebook example based off of what we just CADed. It's very basic what we did, right? We just made a dry base. There wasn't any planning. This wasn't specifically meant to be a robot that would play this year's game, okay? And I just wrote this just now, okay? You can hopefully make a better engineering notebook than I can in like 10 minutes. So notably, I start on entry number 3 because usually for your first few entries, you go over your design, right? You think up these ideas, you document different ideas you have, and then you go into actually CADing it. Okay, but let's say, yeah, on entry 3, you start CADing your robot. Okay, I mean, standard notebook stuff, you always have your title block at the beginning of entry. The entry always starts at the top of the page. Okay, you have an introduction paragraph, and then you have paragraphs detailing what you did and why did you do it, okay, and you have pictures showing what you made in the CAD, okay, and then you have a conclusion paragraph, right? And this is just how it works for most entries, and you want to have very clear progress in your CAD, like being shown in your notebook, okay? And it's fine if you make mistakes. You want to actually document these mistakes and show how the CAD changed, okay? Even if it's a very small, minor thing. And so we can clearly see that it goes from drive base frame with wheels, basically a finished drive base, okay? And then now we have a sketch that's showing the next future steps, like planning out the entire robot. Okay, I'll show you a more robust example with this engineering notebook, okay? This is, I mean, yeah, we're deep in the notebook, but basically we restarted the design process this year for this competition, like halfway through the season, right? We restarted the design process. So coming back, right, there's a entry on why we decided to make a robot like this, okay? We have a diagram here dictating why we chose a certain drive base, okay? And then I start jumping into CAD, okay? I show this CAD here, okay? And then I show create an entire frame, okay? I do a more advanced thing here where I actually create a custom Delrin piece. You know what, I can make a video about that. And the drive base is very clearly coming along, right? And I'm documenting different things I'm doing to dry base, right? It's like first initially like this. I'm pretty sure I moved the motors at some point, or like I adjusted a bit to make sure things are not coming in contact with each other to keep the robot functional, right? Okay, and you'll see, I mean, I'm going through this a bit quickly, but in this photo we have these, they're called localization modules that are built this way, and by the next entry, right, it's changed, and I explain why. It's because we need a tensioning mechanism, okay, in a notebook, and this is basically how it works, right? Because you are making most of your design decisions while you are CADing, and you need to document the design process, right? When you actually go on to build it later, hopefully your CAD is pretty good. So when you build it, it's pretty simple. You just build it, right? I mean, maybe, yeah, okay, I had to like make a small change here, and I did it in the CAD before we continued on building it. But then, boom, right? Look at how fast it progressed because the CAD has already planned out everything we're going to do in the lab, right? And the robot just comes together pretty easily. That's how it works, right? But I just need to stress the importance of taking photos at the end of a CAD session, okay, and documenting it, right? Do not go create a notebook for the example CAD that we just did. That was just a tutorial to get you familiar with Fusion 360, okay? Unless if you plan to actually use that drive base for your team's robot, okay? Then it would be part of your design process, and you want to fit, and then you want to document this properly in your engineering notebook. Okay, that's all I have to say on that topic.